Hello everyone, and thank you for joining my presentation today. My name is Aura, and I'll be discussing the influence of artificial intelligence on consumer behavior in the fashion industry. To start, the fashion industry faces several significant challenges, including trend forecasting, customer support, and supply chain management. These challenges often lead to inefficiencies and environmental harm, as highlighted by Nini Maki in 2020 and Schumacher in 2022. Traditional methods used to tackle these issues are often time-consuming and inaccurate, resulting in financial losses and poor inventory management, as noted by Yan in 2021 and Ferrazzo in 2020. AI technologies offer promising solutions to these problems. However, despite their potential, the adoption of AI in the fashion industry remains limited and not fully understood. Almeida in 2022 and Freitas in 2022 emphasized that comprehensive data and analysis on AI's impact are still lacking. This gap is also supported by Zizopoulos in 2022 and the European Commissions in 2023. In this study, I aim to investigate AI's influence on improving trend forecasting, customer support, and supply chain optimization within the fashion industry. By addressing these key gaps, my research explores AI's potential to enhance efficiency and sustainability. References from Eurotext in 2020, the European Commission in 2023, and Scott in 2015 have been instrumental in shaping the objective of this study. Through this research, I hope to provide valuable insights into how AI can transform the fashion industry, making it more efficient and sustainable. So here are the research questions that I've provided for this study. So the first one is, how familiar are the customers with the use of AI in the fashion industry? The second one is the factors that influence consumers on their shopping behavior due to the AI tools. Next is, how much do they trust AI in forecasting fashion trends, and how do they view AI? Next is the differences in age groups viewing, accepting, and responded to AI tools used. And last one is, do consumers prefer AI-driven purchasing experience, which it is the modern ways or the traditional method, and what drive the preferences? Artificial intelligence was established in 1956 during a Dartmouth College workshop. AI refers to replicating human intelligence in machines, enabling them to learn and solve problems. Initially, pioneers believed human-level intelligence in machines would be achievable within a few decades. AI studies cognitive processes to create intelligent systems. Today, AI is deeply integrated into daily life, like facial recognitions on phones and AI-driven chat systems like ChatGPT. AI's adaptability spans autonomous driving, healthcare, and education, showcasing its transformative potential. AI revolutionizes the fashion industry by enhancing efficiency, personalization, and sustainability. McKinsey predicts AI could boost industry profits by up to $275 billion. AI forecasts trends, optimizes supply chain, and personalizes customer experience, such as virtual try-ons. AI gathers data to predict trends and collaborates with institutions to enhance design and retail. Companies like H&M use AI to adjust production and minimizing waste. AI also personalizes shopping, with companies like ASOS using AI for tailored recommendations. Virtual try-ons technologies improve online shopping confidence. Despite its benefits, AI poses challenges in the fashion industry. Job displacement is a major concern as AI automates roles in design and marketing. This raises ethical questions about balancing technology and employee welfare. AI also stifles creativity by relying on data-driven decisions, potentially weakening brand identities. The industry must learn to use AI to enhance creativity rather than limit it. Consumer behavior studies how individuals, groups, or organizations acquire, use, and dispose of products and services. It involves problem identification, data collection, solution search, purchasing decisions, and post-purchase evaluation. Factors influencing consumer behavior include personal beliefs, social customs, marketing, and external factors. There are four types of consumer behavior: complex buying, dissonance reducing, habitual, and variety seeking. Next is purchasing decision process. So there are five purchasing decision process. First one is need recognition, is where consumers identify a need or a problem. Second is information search, gathering information about potential solutions made by the consumers. Third is evaluation of alternative, where customers comparing products based on criteria like price and quality. Fourth is purchasing decisions, where customers select and buy the best product. Lastly is the post-purchase evaluation. It is where customers reflect on the purchase decisions and satisfaction. So understanding this process helps business create effective marketing strategies in enhancing customer satisfaction and loyalty. Next, we are going to talk about methodology used in this study. In this research, I use a quantitative approach to explore how AI influences consumer behavior in the fashion technology sector. The quantitative methods were selected because they effectively measure variables and establish statistical relationships between them. I designed a structured survey to gather insights on consumers' perceptions, preferences, and behavior related to AI applications in fashion. This survey aimed to understand how AI enhances customer experience and impacts interactions with fashion brands. The survey was administered online, allowing me to collect a wide range of data from various participants. This approach ensures a robust foundation for analyzing how AI affects consumer shopping behavior in the evolving fashion industry. To investigate the impact of AI on consumer behavior in the fashion industry, I designed and executed the data collection process. So first is questionnaire design. I developed a comprehensive survey based on thorough literature review of fashion, consumer behavior, and AI trends. The questionnaire was crafted to address key aspects such as consumer knowledge, impressions, and habits related to AI assisted fashion tools, including virtual try-ons, personalized recommendations, and AI-driven fashion forecasting. Second is survey distribution. I distributed this and was administered over a 4 weeks period, allowing participants a full month to provide their responses. This approach aimed to maximize participation and gather a diverse range of insight. Third is participant selection. I targeted the individuals who frequently use AI tools in their shopping routines, ensuring the data would be relevant to the research objective. Next is data handling. Once the survey period ended, I extracted and cleaned the data, addressing any missing or inconsistent answers. This step was crucial for ensuring the accuracy and reliability of the analysis. Overall, the structured and thorough data collection process was designed to provide reliable and meaningful insights into how AI influences consumer behavior in the fashion industry. To determine the sample size for my study on AI's impact on consumer shopping behavior, I used a common formula for my exploratory research. So first, N is the sample size needed. The big N is the estimated size of the population. E is the margin of error expressed as decimals. So in this case, N is the estimated population of 100,000 online consumers using AI in fashion. E is the set at 0.05, which corresponds to a 5% margin of error. Plugging these values into the formula, the calculation yields a sample size of 120. The general idea of this formula is to balance the need for a large enough sample to ensure reliable results while also keeping the sample size manageable. a sample size of consumer behavior without requiring an impractically large number of responses. This approach ensures that the findings are both meaningful and feasible given the resources and time available. In this study, the descriptive analysis was designed to gain insights into the demographic of my respondents. I focused on key factors such as gender, education, income, age, and their interactions with AI in the fashion industry. To achieve this, I utilized SPSS software, which allowed me to create detailed profiles of the respondents and accurately represent the collected data. In addition to look at the objective data, I also examined how participants felt about each survey questions. For this, I used a 5-point Likert scale, which helped me understand their perceptions. So 1 to 8 is very disagree, 180 to 6.6 is disagree, 2.6 to 3.4 is quite agree, 3.4 to 4.2 is agree, 4.2 to 5 is very agree. So the range of values I calculated helped me to sort responses into these categories, allowing for a clearer interpretation of how respondents view different aspects of AI in fashion. Moving on to findings. So first is measurement model. This is the conversion validity table. Conversion validity checks if indicators within a construct are well correlated. Indicators with loading factors above 0.7 are considered valid. In this study, all indicators for constructs such as trust and preferences, consumer perceptions, data security, future outlook, additional insights, and consumer shopping behavior had loading factors above 0.7, confirming their validity. So next is discriminant validity. Discriminant validity ensures constructs are distinct from each other. The formula Likert gradation is used to compare the square root of the average variance extracted with correlations among constructs. Results show that the diagonal values were higher than off-diagonal correlations, confirming that each construct uniquely measures different aspects. Next is reliability and conversion validity evaluation. Reliability and conversion validity were assessed using Cron-Bench alpha, composite reliability, and average variance extracted. All metrics indicated high internal consistency and reliability. Cron-Bench alpha and composite reliability scores were above 0.7 and AVE values were above 0.5, showing that the construct reliably and validly measures their theoretical concepts. So next is evaluation model fit. R-squares values assess the fit of the BLS-SEM model by showing how much variance in the dependent variable. Purchase intention is explained by the independent variables. The model's R-square value is 0.910, meaning it explains 91% of the variance, indicating strong explanatory power. The adjusted R-square value is 0.906, which accounts for the number of predictors and confirms the model's efficiency. The close alignment between R-square and adjusted R-square values highlights the model's effectiveness is capturing the relationship between variables. These results validated the model's robustness in its capability to explain the impact of AI-powered fashion trends on consumer shopping behavior. So moving on to structure model, the diagram in figure 1 highlights the potential positive influences of independent constructs on the dependent construct. Path coefficients measure the degree of influence of each independent variable on the dependent variable. These statistics and p-values provide statistical evidence to support or refute each hypothesis, assessing the significance of these relationships. This structural model helps in understanding by directing and combining effects of marketing dimensions on consumer behavior by examining how trustworthiness, expertise, and congruence contribute to purchase intentions. The model offers insights into the mechanics of influencer marketing within the context of counterfeit luxury goods in Indonesia. These insights are crucial for marketers and policymakers aiming to mitigate the impact of counterfeit sales through informed strategic planning and executions of influencer marketing campaigns. The analysis guide strategic decisions and contribute to the broader discourse on marketing ethics and consumer protection in emerging markets. Moving on to the hypothesis test, the analysis of the hypothesis testing reveals several important insights into consumer behavior in relation to AI in fashion. So first is additional insights. This factor shows no significant impact on consumer shopping behavior with a p-value of 0.742, indicating that it does not influence buying decisions in a meaningful way. Second is consumer perceptions and trust. The impact of consumer perception and trust on shopping behavior is marginally significant with a p-value of 0.069. Although the effect is positive, it does not reach the conventional significance threshold. Third is data security and transparency. This factor has a significant positive impact on consumer shopping behavior with a p-value of 0.000. It indicates that concerns about data security and transparency strongly influence consumer behavior, highlighting the importance of these aspects. Fourth is future outlook and AI tool usage. The influence of future outlook and the usage of AI tools on shopping behavior is highly significant with a p-value of 0.000. This suggests that consumers' positive expectations and the use of AI tools significantly affect their shopping behavior. Lastly is trust and preference. Trust and preference are also have a significant positive impact with a p-value of 0.014. This underscores that trust in AI recommendations and personal preference are key drivers of consumer behavior. In summary, significant factors influencing consumer shopping behavior include data security, AI tool usage, and trust. Addressing these areas effectively can enhance the adoption and impact of AI in the fashion industry. Moving on to conclusions and recommendations, this study explored the influence of AI-powered fashion tools on consumer shopping behavior, focusing on how AI has introduced new dynamics in consumer engagement within the fashion industry and the consequences of these developments. Key findings include several important aspects. First, a significant number of consumers are not only knowledgeable about AI-driven fashion tools like virtual try-ons and personalized recommendations, but they are also actively using them. These tools enhance the shopping experience by offering more direct alignment with the individual preferences and post-buying patterns, which increases customer satisfaction and loyalty. However, there are substantial concerns regarding data security and the potential misuse of AI systems, which could hinder the adoption of these technologies. Additionally, adoption rates vary based on demographic factors. Lastly, while AI simplifies supply chain and reduces waste, supporting environmental sustainability, it also poses challenges such as job displacement and potential homogenization of fashion trends. Moving on to implication of the research, the findings of this research have several implications for both theory and practice. For retailers and designers, integrating AI into fashion retail can significantly enhance customer satisfaction and operational efficiency. Fashion brands should continue to invest in AI to tailor shopping experiences and predict future trends effectively. For AI developers, it is crucial to address privacy concerns by improving the transparency of AI system and ensuring the secure and ethical handling of consumer data. Policymakers also play a vital role by implementing stricter regulations to govern the use of AI in consumer markets, ensuring that consumer rights are protected in an increasingly digital shopping environment. Next, for the limitations of the study acknowledges several limitations. Firstly, while the sample size is adequate for initial analysis, it limits the external validity of the findings in a global consumer population. Secondly, potential biases from self-reported data could affect the validity of this result. Lastly, the dynamic and rapidly evolving nature of AI technology means that the findings may not capture future developments, making it necessary for continuous research in this area. So, for recommendations for future research based on the findings and limitations of the study, several recommendations for future research have been identified. Expanding the sample size and including a more diverse demographic would enhance the generalizability of the result. Conducting longitudinal studies would allow for the assessment of the long-term impacts of AI on consumer behavior. Additionally, exploring the psychological impact of AI interactions in fashion retailing would provide a better understanding of consumer trust dynamics, which is crucial for the successful integration of AI technologies in the industry. For the conclusion, AI-powered fashion technologies are transforming the fashion industry by enhancing shopping experiences, improving operational efficiency, and contributing to sustainability. While these technologies offer significant benefits, addressing challenges related to consumer trust, privacy, and the ethical use of AI is crucial. By overcoming these challenges, the fashion industry can better harness the potential of AI to meet consumer needs and drive digital innovation. That is the end of the presentation. I hope that this study helped you to understand more about AI tools in fashion industry. Thank you for your attention and time. Have a good day.